Okay, let's kick things off. Welcome back, everyone, to session 3 of the Sysmac programming webinars. This session, I think, will be the most beneficial of all the sessions. This is where we go from basic PLC programming to getting into more of the advanced programming topics in our controllers. This is where we learn how to optimize our programs, work with structures, function blocks, that sort of thing. Certainly going to be a lot more interesting and beneficial for everyone on the call, I hope. So let's kick things off here. So on the agenda, very quick here, we're gonna first go over structure creation, or UDTs, they're often called, complex data types. Then we're going to cover something in Sysmac called an offset type. And this will go hand in hand with structure creation. So it's a very important concept of creating a structure, and it essentially lets you determine the variable spacing, where the data will reside in that structure. Sometimes it's important, sometimes it's not important, but when it is important, you really need to know how to do it, and we will go over how to do that. Then we will make a quick custom function block. We'll walk through the programming environment for custom function blocks, which is essentially, in other platforms, they're called AOIs sometimes, but a reusable chunk of code that we can make as many instances of as we want and really cuts down on programming time. After that, I'll get everyone to grab a library that I distributed in the student material folder, and we'll walk through how to import that library into Sysmac Studio and how to access the library function blocks from Sysmac Studio. Then we're going to take that library that we imported and we're going to add it to our lift station. There's a function block I made that will actually simulate our tank level for us. So that'll help with simulating this. We can kind of just sit back and watch the tank fill and drain automatically. Then we'll do a quick exercise that is very relevant when you're working on large projects. So essentially mass manipulating your variables using Excel. So we can freely copy and paste to and from Excel in Sysmac Studio. We don't need to go through an export process and an import process. We can just cut and paste to and from Excel. And we'll walk through a tag exercise in our PLC project. Then if we have time at the end, we'll go over something that I refer to as bit extraction. So this becomes very relevant when you're dealing with communications. You might have 13 status bits packed into a word of data, and you need to get those status bits out. Or on the other hand, you may need to pack 13 signals into a word of data and send that across the network to a device. And it's not too apparent, at least in everything that we've covered in Sysmac, how to do that. So we're gonna go over a few ways that we can do that in Sysmac Studio. Okay, so Sysmac Studio structures, commonly called UDTs, are essentially a custom-made data type to suit your application. So some people like to go way overboard with these and have every variable in their controller part of a structure. You can nest structures, you can have arrays of structures. It's really up to you. We're not gonna go too crazy with it on this one, but it essentially allows for parent-child tag access. A lot of you, if you've worked on a tag-based controller, you're familiar with this. A lot of even PC-based programming involves the parent-child tag structure, and you can do similar things on that. So we are going to create, as a quick exercise here, we're going to make a UDT for a VFD control word. So if you've worked with those before, these should look fairly familiar to you. But essentially, this has a word of data, and it has 16 bits packed into that word of data. So we're going to make a structure for this. And instead of addressing this by the bit number, like you could in some platforms, we're going to actually have a Boolean that we can call by tag name. And that's how we'll access that bit within our structure. So if you haven't already, please open up your Sysmac Studio, and you can either save a new copy of your lift station if you want to kind of preserve where we left off, or you can work with your existing project. It doesn't really matter. This VFD UDT exercise isn't going to be used in the project, but if you'd like to have all your reference material in the same place, you can go ahead and add this to your project. So I'll get everyone to open up Sysmac Studio. And in your Multi-View Explorer, we are going to go down to right above global variables. In the data section, we have data types. When you double click on data types, it opens up all the data types you've created, which so far we haven't created any. Unions and enumerated, we're not going to touch on yet. Structures are essentially probably the UDTs that you're familiar with. I'll give everyone Sysmac a second to load up here. Now, when we click in structures, when it's empty at least, it will create one by default for us. So we can just click there and it's going to create a structure for us. And the offset type will be NJ. We will touch on the offset type very soon, but we are going to name our structure VFD underscore control underscore word underscore NJ. And that NJ pertains to the offset type. Now, to create a member for the structure or to add a data point to our structure, we simply right-click on the structure, the base here, and we choose Create New Member. And that will add a member to our structure. We are going to be creating quite a few members in this structure. I'm just going to create a whole bunch of them here. And then I will go back to the PowerPoint and you guys can fill these in on your own. I think there are 10 of them or so. So once you've added a bunch of members to your structure, you can label them the same as my structure on my screen here. And this is just a screenshot from the manual of a VFD that we're essentially going to be theoretically setting up communications with, and we just want to match that structure that's in the VFD in our PLC. So I'll leave this on the screen here, and I'm going to build my structure on my other screen here. You guys can go ahead and do the same. If you need to add more members, just right-click on the VFD control word NJ and choose Add New Member. I'll give everyone a minute or two to build their structure. So is anybody having any issues building their structure so far?
I don't have the offset type.
You're in structures?
Yeah.
The structures category?
All I have is base type and comment.
I have never heard of that happening. Did it by chance get, I wonder if we could, is it by chance just closed off like that? If you drag to the left of offset byte, does it reveal it?
Nope.
No? Or
I have
some of
a
the
light.
other ones?
I have the same thing.
I have a light version. I don't know if that restricts it but.
I didn't think it did.
And then the base type says Boolean, not bool. I don't know if that, how that.
Yeah, they're kind of used interchangeably. Maybe not.
I don't know if that's a setup thing or something.
Interesting. You're in root up at the top here?
Yep.
Okay. And you're in structures for sure, not union or enumerated?
Yep.
Is anybody else using the light version and experiencing that?
Yeah, I am.
I'm using it, but
Same
it seems
here.
to work correctly.
Well, that is a first. I've done this for 4 years, lots of people on the light, and I've never heard of that. Okay.
That's all right. Go ahead. I'll work on it and see if I can.
Yeah, I mean,
can you send a screenshot to chat? Wilson's asking for it, and he can help behind the scenes.
Okay.
I didn't think that was something we could even disable, short of hiding it behind that, but interesting. Okay. Well, yeah, thanks, Wilson. Maybe he can point you in the right direction. All right. So does anybody need more time building their structure? Okay. So now that we've built a structure, this is essentially a data type as far as our PLC is concerned. Just like integer is a data type, just like real is a data type. So when we create a variable, and everyone can go to their global variables and make a new variable, just right click anywhere and choose create new. Alternatively, insert works as well. Now when we create a variable, I'll just call this VFD123. Now when I select my data type, I will choose VFD control word NJ as my data type. I'll expand this a little bit here. And now VFD123 has all of these members associated with it. So now don't play along with this part. I'm just showing you what that looks like in logic here. But if we were, I'll just throw a rung in down at the bottom here. So I had my VFD123 dot, and now I have all the members from that structure at my disposal. So it makes a lot more sense to make a structure than say VFD123 bit number 4, and we just have to remember what that does, or make an elongated comment explaining that bit 4 is your in data number 1 from the drive kind of thing. So now we're not limited to Booleans as far as structures go. We support any data type, arrays of data types, structures, arrays of structures. We can nest structures multiple layers deep if we want to. So it's very nice in a tag-based programming environment to clean up your code. And it is borderline essential when you're doing communications with some devices. And in the communications class on Thursday, we're going to use our structures when we set up communications with a device. And you'll see just how convenient these structures can make your life when you're working with communications. So any questions on structures before we push forward?
One clarification from me, Peter. I think several people did this too. I think I just made my data types in the HMI rather than the controller. So if you go back to the controller, you get the offset type.
Oh,
Yes, good observation. Now that I open up that screenshot, I can see it's the HMI. Yep.
yeah.
So yeah, make sure your controller is selected because they do look similar and they do both have data types.
All right, thanks.
And yeah, gold star, Peter. If you were here, I'd give you an all-run screwdriver. Okay. So if you want to grab a screenshot of this before we move on to get caught up, feel free. Those of you who need to rebuild that structure on the PLC.
Okay, got it. Thanks.
Okay, so now one thing that goes hand in hand with structures is something called offset types. Now we have three options for an offset type. We have NJ, CJ, and user. And what the offset type determines is how the data is essentially packed into our UDT, our structure. Now, when we have the NJ offset type, it keeps blocks of 32 bits allotted to each variable. So if your structure was all reals, that really wouldn't matter because a real takes up 32 bits. If your structure was all Booleans, like our NJ control word structure that we built, each one of those Booleans is going to take up 32 bits, regardless of it only using one of those bits. And this is something in most PLCs that happens when you create anything smaller than the minimum increment of the CPU architecture, essentially. So what we do have as a workaround for that is an offset type called user. Now, this lets you pick exactly where in your structure that these members will sit from a data spacing kind of data layout perspective. So you'll notice in the screenshot here, there's this offset bit and offset byte column. So we can tell the PLC when it makes a variable of this data type, of this structured data type, how this data should be spaced out. And we're going to do an exercise at the end of this, and you'll see what kind of effect this will have on the size of the structure. It's going to be probably a bit surprising. So to illustrate this, though, we are going to just copy and paste our control word NJ, and we're going to rename it control word underscore user. And we're going to change that offset type to user, and then just fill in your bit and byte offsets like they are on the screen here. So I'll give everyone 2 minutes to do that. Did anyone need a little more time for the second structure? Okay, now everybody can play along with this part now. We'll go into our global variables and we'll make another variable in our global variables, but we're going to make it the data type VFD control word user. And you can call it whatever you want. We're not actually using this in our project. It's just an illustration to demonstrate how the offset type affects your actual data type and its layout. So now the next thing I'll get everyone to do, in your global variables, there's a column here, and it's called network publish. We're going to learn more about this in the communications class, but if we can change this to input, both of them to input, this is going to let us check the size of the variable, because we'll start assessing it for communications use. So don't worry about what exactly network publish does for this class, but for this example, change network publish to input. And then I'll get everyone to go up to Tools, Ethernet IP connection settings. Then you can double click on either Ethernet port, it doesn't matter for this. And it will bring up your tag set window. Down at, on the right-hand side, there's a button that says Registration All. And if we click on that button, it will show all tags that we've assigned for Ethernet IP, which are those two structures that we created. What it also tells us is the size in bytes of that structure. Is everyone able to navigate to the tag set page? Okay. So as you can see, when we stick with the NJ offset, it's optimized for use in the CPU. It works in increments that the CPU processes data in already. But if we were actually communicating with the VFD, we would have to set up this as a user offset type, because this would not even match the size in the drive. So again, we'll revisit this a little bit on the communications class, but very important aspect of creating structures is the offset type, and this is essentially why. So the rule of thumb is if the structure is going to stay in your PLC and you're just using it to make programming more convenient, stick with the NJ offset type. It's optimized for use in your program. If it's for communications, you'll most likely have to stick with a user offset type. Because if you recall in our VFD data sheet here, that is how they packed their word, their control word in their VFD. So there's absolutely no way we could communicate this NJ structure to this control word in the VFD. So for communications, user offset type, anything local to the PLC that doesn't need to get outside of the PLC, stick with the NJ offset type. Any questions on structures or UDTs or offset types before we move on? Okay. Yeah, we did that. Okay. So next thing we'll touch on here is we went over how to create our own data types. Now we're going to go over how to create our own function blocks. What this is, if you're familiar with a text-based language, you could think of it as a subroutine almost, but it's a reusable chunk of code that you can create as many instances of as you need. They are online edit friendly. This is something we're pretty proud of. Not everybody can do this. Structures can be utilized to have an entire function block of any size consume only one variable. So you can pair custom function blocks with custom structures if you'd like. You can even make objects on the HMI that utilize your custom structure as well. And you can really cut down on your programming time if you need to. Now for our exercise, we are going to create a function block for the lift station pump motor. The inputs will be start, stop, reset, and run feedback. Our outputs will be the run command and a fail to start alarm. So in Sysmac Studio, you can close out of all of the Ethernet IP stuff if you'd like. It doesn't matter if you leave it in your project, we're not using it, and it could be a good future reference for you. But you can close out of everything Ethernet IP related that you opened up. Now in our programming section of Sysmac, we have a section called functions and function blocks. So we can create a function or a function block. And just for clarification purposes, function versus function block, if you're not familiar with those two, a function is something that doesn't need to retain any data for the next execution of that function. So a good example of that from our common programming instructions would be some of the math instructions. So you open up one and pick one here. So you can see in the math instructions, every single one of these are functions. They have an F instead of an FB. But if you're dealing with motion control, for example, you're almost always going to have a FB or a function block. So a function, if we took an add instruction, for example, we will add these two numbers together. We'll put the result in the output. And we don't need to retain anything for the next execution of our program. If this were a timer, for example, we would obviously need to remember what was the system clock time when this timer was started so that we can gauge the elapsed time. We can calculate the elapsed time and we know when to actually turn on that output. So we need to retain something for the next execution of this function block. That's essentially the difference between a function and a function block. For this exercise, I'll get everyone to make a function block. So to make your own function block, you can right-click and choose Add, and you can pick your programming language. I'm going to stick with ladder since probably most people are familiar with it. And it will add function block 0 to your list of function blocks. We can right-click on function block 0 and we can rename it. We'll call it pump control. Give everyone a second to create their own function block for pump control. Now, when we double click on pump control, the environment that we're presented with looks very similar to our ladder logic programming environment. But where this differs from the ladder logic programming environment is up top in the variables tab here. So if we hit this arrow to the right of where it says variables at the top of our logic, it's going to drop down And there's a new category there. And it's called in/out. So we have internals, in/out, and externals. So internals are going to be things that are local to our function block. They have no need to get outside of the function block. In/out variables are going to be things that are exposed on the outside of the function. So if we were looking at a math instruction, actually, let me use a timer as an example here. So if we were the ones building this on delay timer, our in and out variables would be PT, ET, and Q. Those would be in/out variables. They're exposed to the outside world. And externals, these are any variable that you want to bring into your function block, but you don't want to have it exposed on the outside. So you may have a system bit in your PLC for an emergency stop or something like that. And you could specify that tag here from your global variables of your PLC, and you can access it that way. The catch there, I guess we'll say something you need to be a little cautious of is if you were creating this function block and redistributing it to other people to use in their projects, it's not going to compile unless they have that exact external variable in their project. So they can be convenient, but they can be confusing, is what I'm trying to say. So I generally don't use them, but there definitely is a use case. And if it's just for your project and you have way too many in/out variables and you could get away with moving some of those to externals, sure, that would be a good use case. So the function block we're going to create is going to be just a basic start, stop, pump control, but something we didn't do on the first class is add run feedback and a fail to start timer. So the first thing we're going to do, and you can create them as you go, or you can create them and then program your code. It really doesn't matter. Because when you create a variable, and you guys don't need to follow this exercise here, but if I just made test bit a variable, now when I create a new variable, it's going to ask me where I want to create it. Is it going to be an input, an output, an in/out, internal, or global? So again, you can create the variables as you go, or if you know what they all are ahead of time, you can just fill in your in/out variables. Input variables will be on the left-hand side of your function block. Output variables will be on the right-hand side. And in/out variable is essentially whenever you want to use a structure or an array in your function block, you would use an in/out variable. And that appears on both the left and the right-hand side of your function block, but not something we're going to do today. So I'm just going to make that test bit an internal. We're not actually going to use it. So I'll go back to PowerPoint here. And on my next slide, we have the tags that we require for our function block. We have whether they are an input or an output. And then we have our logic right below it here. So the order which they are created in your in/out variable list here is the order which they are displayed on the outside of the function block. So you may be picky about the appearance of your function block, and if you needed to shuffle these around, you can drag them, shuffle them, and it will control the way they appear when you actually use this function block in your ladder logic. So everyone can go ahead and create their motor control function block. I'm going to work in the other monitor and I'll leave this up on this screen for you guys. So I'll give everyone a few minutes to replicate what's on the PowerPoint there. So anybody having any issues or questions regarding the logic? Don't try to understand the logic. It's there is an issue with it and it's intentional. So just duplicate it and we'll do a debugging exercise when it actually comes time to test this function block. So if you're scratching your head looking at the logic and think something's a little off, that's because it is. Did anyone need any more time with that?
Yeah, I could use a little bit more. I didn't realize we were recreating the logic, so I kind of sat for a second. You can give me a second.
Yeah, no worries. Yeah, Kevin, I know you'd missed the first session there. Where you're going to find all the contacts and coils are in the toolbox on the right-hand side. There's a category called ladder tools. You'll have one contact and one coil. And if you need to change what it does, whether it's normally closed, normally open, or set, reset, in the case of an output, you right click on it and you can choose set or reset, diff up, diff down, that kind of thing. So now we're good for time today, so we'll wait just a minute here for everyone to catch up.
And thanks. Sorry about that.
Oh, no problem. Does anyone care to fancy a guess on the bug in the logic while we wait here?
Your run motor latch.
Correct.
Does the label on your timer mean anything or that
No, it-
TFTS time?
No, it doesn't.
Okay. Okay.
And you may have noticed, that's actually a good point to bring up. You may have noticed when you created it, it didn't actually prompt you, do you want this to be internal, external, in, out? The T on data type for that timer is by default going to reside in the internals. So yeah, it really doesn't matter because it's an internal. If we
Okay.
wanted to monitor that time from the outside world and we created something on the elapsed time, then it would prompt us. But yeah, the time
Okay.
data type itself, yeah, it doesn't matter.
Okay.
All right, everyone get the logic built?
Yeah, I'm good. Go ahead. Thanks.
Okay, perfect. All right, so everyone can go onto their pump logic. And we'll add a new rung down at the bottom of the program here. So you can right click and choose insert rung below, or you can type R if you're a hotkey programmer. And now we are going to go into our ladder tools, and we are going to drag a function block onto the rung. You could also type F, click on the rung and type F, and that does the same thing. Now the name of the function block is going to be what we named our function block, which is pump control. So double click where it says function block, and we are going to type pump, and it should autofill it to pump control for you. Name it whatever you want. I'm just going to call mine test pump. And the parameters that are visible, or the exposed variables, should look familiar. And the order in which they appear should match the order in which we created them in this list. If you wanted to change them, you can drag this kind of dotted checkered box to the left of the variable name, and you can actually move them up or down if you wanted to change the appearance of how they look in the actual logic. For this, doesn't really matter. So we'll put a contact. We'll go ahead and tag all of the inputs and outputs on this block, just with Booleans. They can be internal. It doesn't matter. Okay, and once you have those tagged, you can fire up your simulator. So in case you don't remember where the simulator is, on the Windows menu at the top, we go to Simulation, Run. We don't need the HMI for this, so just run it as the PLC simulator. Now, because we require a run status, I'm going to just double click on my run status and set that true, so we don't have to worry about that fail to start alarm kicking us out. I'm going to reset my reset input. And now something is obviously not working correctly with this function block. I don't have my start input on, but my run output is on. If I stop it, it turns off, but as soon as I clear my stop, it turns back on. So that's not going to work very well. If we want to explore the logic of this specific instance of the pump control function block, we can right click on it and we can go to lower layer, which is the very last option. And that will open up the logic of this instance of this function block. We can have countless instances of this function block, and we can look in a specific instance of it. Okay, now somebody pointed out the bug earlier, and it looks like instead of making a latching variable, we made a start motor normally closed when it should be a run motor normally open. So we can edit our function blocks online, both in the simulator and on the PLC. So if everyone wants to right click on rung 0 and go down to online edit, start, this is going to edit the base instance of this function block. It's not going to edit the instance we're looking at. It's going to edit the base instance, and it's going to be reflected on every instance of it. So you might have 100 instances of this function block in your project. And when you accept this online edit, they are all going to have this change reflected in them for the next scan cycle. I'll let everyone fix their function block with their online edit. And then we'll send our online edit the same way that we started it. So right click on the rung number. You can actually right click on any rung number in this project. The entire project, or sorry, the entire function block is available for edit. It's not just one rung. So then you can go to online edit, transfer. Yes. And now that change is active. So we can go back to our logic where we were testing out this instruction, and we can stop our motor. And we can see if it will now behave how it's supposed to. So it latches, it unlatches. And if it's running and it loses its run feedback, I made my time a bit longer, 7 seconds. Oh, we'll have to turn off our run status here. Yeah, there we go. Now we'll see our timer has been activated. I used 7 seconds just so I would have a bit more time. And now our fail to start alarm works. So you're welcome to test your function block out while you have the simulator running. Was anybody having any issues getting this far with either the simulator or the online edit? Okay, awesome. We can stop our simulators now. Now we're going to talk about libraries in Sysmac Studio. So Omron has libraries that we develop and distribute for a lot of our different components. For example, if you had some temperature control that you needed to do, we have a temperature control library. If you play a lot in the motion world, we have a lot of different motion control libraries that we distribute. And alternatively, you can make your own library if you wanted to standardize on a set of function blocks and distribute this to your development team so that they're all working off essentially the same template. Now, in the student material folder that I sent out, Just going to open it up here. Can everyone just open up that student material folder and make sure that you have session 3 training library.slr. If anybody didn't get this, let me know.
Which packet was that in? PLC libraries?
Nope, so it's going to be under session 3. And then there's training library.slr. Now let me expand that a bit so you can see it.
I think I didn't get to session 3. Oh, wait. Yeah. Go ahead. I'll have to download it.
Let me, yeah, so I did this. Did you get the Google Drive link that went out ahead of time?
I did, yeah, and I was trying to get all that stuff on my computer right before it started, and I got session 1 and session 2. Apparently, I did not get to session 3.
Okay.
Anyway, sorry about that.
No worries. I put them in chat. I'm not entirely sure you'll be able to download them being outside of the organization, but you could try. But they'll still be on that Google Drive link. I'll grab that Drive link for you right now.
Okay, yeah, I found it. I just have to do the download here. Sorry, everybody.
Oh, no problem. We're pretty good on time, so. Anybody else not have that training library.slr? Okay, so how we access the libraries in
Sorry,
Sysmac.
what program? It's asking me for a program to open it up, so I have it. So
Oh yeah, yeah. Yeah, so don't worry about it as long as you have it. Just make sure you know where it is, because
right,
you'll have
perfect.
to navigate to it in Sysmac. Yeah, no worries.
I think I'm finally caught up.
All good. Okay, so in Sysmac, and make sure you're in the PLC, we're going to go up to Project, Library, Show References. This will bring up our library reference page. So we can point to one library, we can point to 50 libraries. When we click on the plus sign down here to create reference, it's going to bring up a file browser. And everyone can navigate now to the student material, session 3, training library.slr, and click open. And this will add the training library to your project. And if you expand it, you can see what's inside of it, which in our case, it's just one function block and a data type to go with it, I believe. But don't worry about that. Once you've added it to your library reference, you can go ahead and click OK. And now you may have noticed in your toolbox at the top right, it usually drops it at the very top, there's a category called Training Library. And if we expand that, we've got an analog sim function block that was included in that training library. I'll give everyone a second to get that added. And if you're having any issues, let me know.
Yeah, sorry. I can click the plus sign, and then I seem to have gotten lost.
Okay,
so I
so
hit plus,
And
And
then you'll navigate to that file I just had you download.
that's where it's not letting me go. It's probably my computer.
Okay, yeah, you might have to throw it on your desktop. You could try. I'm not sure what your administrator rights are like on your PC, but
Well, I found the folder. Yeah. All right. See if I can figure this out.
yeah, it might be the location that it's in, and it might be an administrator right thing on your PC. I'm not sure if you've got that kind of locked down on your end or not.
I just drag it to my desktop. Let me see if I can go there.
Okay.
Yeah, that works. So I double clicked on it and yeah, it did something.
Okay,
What am I?
perfect.
I'm not sure. What am I supposed to see?
So up at the top of your toolbox now, there should be a category called Training Library.
Oh, yep, got it. Okay.
Yep. So expand that, and then we're going to go to our tank level program. So if you expand program 0, you should have tank level and pump logic. We'll go to tank level. And now we're going to drop this analog sim function block, just drag and drop it out of your toolbox like it's any other instruction. We'll put it at the start of the run. And what this does is this will simulate our real value of 0 to 8,000, which our scale trans block is already set up to interpret. So we can go ahead and delete int to real now. And all we're going to do for this analog sim block is, because it's a function block, it needs a name. So we'll call it our simulation function block. It really doesn't matter what you name it for this. And for our sim value, we are going to simulate the tank level real, which is going to the scale transformation block. You do not need to fill in sim min or sim max. They are defaulted to 0 to 8,000. If you had a high res card and you wanted to use this, you could fill in 0 to 30,000, whatever your card resolution is. But for the default is 0 to 8,000, so we don't have to fill in anything on min and max. Once you've got that function block named and you've added tank level real as the sim value, you can fire up your simulator, which should be ready to go just in the bottom right-hand simulation pane there. Okay, so now we should have a changing tank level that's going to kind of vary up and down. And this is getting fed into our scale transformation block. So now when we're simulating, we don't have to keep going back down to our watch window, changing our tank level raw. We can just start our plant, give it set points, and we'll see our motor toggle on and off automatically. So makes the simulation of our lift station a bit easier to use. But that's primarily an exercise in adding a library to your project and then grabbing something from the library. So we can stop our simulator. You'll have, if you'd like to play around with it using that simulation function block, by all means, you're more than welcome to. We are should have enough time for the next two exercises here. And hopefully everyone has Microsoft Excel for the next one here. So the next exercise that we're going to do is called mass tag manipulation using Excel. So a lot of times when you're working on a project, you have an Excel spreadsheet of instruments, or you might have a control narrative that lists alarm set points, something like that. And it would be very convenient if you could create tags in your PLC that matched the rows of your Excel spreadsheet. So like I mentioned at the start, we can copy and paste freely from Microsoft Excel. I haven't tried it with OpenOffice or any of the other sort of spreadsheet editing programs. But our session 3 student files should have a document, an Excel spreadsheet called tag exercise in it. So this one, I'll get everyone to open up device list.xlsx. And it should look like what I have on the screen here. Anybody having any issues opening the document? Okay, so this is a document that our process engineer made. It's certainly not in a format that Sysmac is going to like, but it's really not too hard to get it into the format that Sysmac is going to like. We just need an example of that format. So the way that I like to do this is if we go into Sysmac and we go into our global variables, we can pick a tag, any tag really, grab one that isn't retained, doesn't have a publish, but it has a comment, is what I like to grab. If you don't have a comment on any tag, you can just add a comment. And we're going to click to the left of the tag name. We're going to right click. We're going to choose copy. Control C works as well. Then we're going to open up go back to our spreadsheet. And right below our list of instruments, we are going to paste that tag. And I like to use keep text only as the option. So I just pasted the format that Sysmac Studio is expecting. So it has a couple columns here. Obviously, the tag name, the data type. It has retained constant columns on it. It has our publish column and it has the comment column. It's the same order as in your global variables. So what we can do now is manipulate the data in our spreadsheet to match this format. So you can copy and paste the instrument name, put it underneath tank level scale, because this is what we'll want our tag name to be. These are all going to be reals. So if you grabbed a Boolean, you can just type real. And then to make our life a bit easier, we can just click the bottom right corner of that and make all of these the real data type. They're all going to be false and false for these other columns. They're all going to be do not publish. And we can take the comment, the location comment, and we can copy and paste that right underneath the tank level value comment. And that will show up as a comment for our tag. So I'll leave this here for a second while everyone gets caught up. This is a common exercise, especially when you're exporting from a PLC and importing into an HMI, for example. I'm sure a lot of you have done that. Anyone's having any issues, let me know. Okay, did anyone need more time? All right, we've got some experienced Excel users on the call then. All right, so now when it comes time to bring these back into Sysmac, we're going to click on the top left item, which is FIT 1100, and then we're going to shift click on the very bottom right comment, which is distribution pressure, and that will select everything that we created underneath our example that we pasted from Sysmac. So right click on that group, choose copy. And then we'll go back into Sysmac Studio once we've copied it. And we are going to paste it right into our global variables. Now, if you accidentally copied the example tag as well, which is tank level scaled, I picked, but yours might have been different. There will be a prompt that will ask you which one you want to keep. So there is duplicate detection, and it's you can quite easily select replace all or reject all duplicates, that kind of thing. But this is a very handy feature in Sysmac. I was recently working with a customer who wanted to change communication protocols to OPC UA recently. And what that involves is changing the network publish column on every single tag that you want to expose to your OPC UA server to publish only. So he had approximately 10,000 tags on his controller, and he wanted to expose about 1,000 of them. We accomplished it in Excel in about 5 minutes, where doing it tag by tag would have taken probably 5 hours. So a really handy feature, especially if you're working on a big project and you have documentation that exists in Microsoft Excel already. So any questions on that tag exercise, or was anybody having any issues? Okay, awesome. So our last exercise for the day is something that I like to call bit extraction. So lots of times, and if you've worked with Modbus, you've probably had to do this quite a bit. You'll get a word of data in the PLC in one form or another, and you need to extract, for example, the third bit out of that word. Now, in some platforms, you can address this variable, and you could say sumvar.3, and if you wanted to pull the Boolean value from the third bit. Now, we don't support that in Sysmac. The IEC 611 standard doesn't support that either. So there's something that we can use which makes this very easy to do. You may have noticed the AT column in all of the variables in our global variables. There's an AT column. Now, this was originally implemented as a way to assign an address to a tag for communications backwards compatibility, but we can also use it as a very convenient way to do bit extraction, data type conversion, bitwise data type conversion, that sort of thing. Now, this will not, this is my disclaimer, this will not detect duplicate addresses or overlapping addresses. So you do need to be careful of it, just like you do when you're programming an address-based PLC. But by using duplicate addresses, we can essentially pull the bits out of a word, for example. So the first thing we're going to do is in our Multi-View Explorer, there's a category called Memory Settings. By default, at least on the NX102 PLC, this is turned off. So we're going to go into, and wondering, yeah, so configurations and setup, controller setup, memory settings. And we are going to enable, and I'll just pick DM memory. I'm going to check that off. We don't need 32,000 words by any means, but we can just leave that default. And then we'll go into our global variables. And we are going to create two variables. The first one is going to be a word. The second one is going to be an array of Booleans. So just bool, square bracket, 16, square bracket. You can give them names. Now, in the at column for those two new variables, this is where we are going to assign an address to them. So the syntax for that address is % and then the memory area, and we enabled memory area D. So %D, and I'll just give it 1, %D1. And we're going to give that to both of those variables. Now you may have noticed the retain box is pink. So you can check off retained. That's just a requirement for using the D memory because in the old controllers, the D memory was retained. So it's kind of a backwards compatibility thing. Anybody need some more time with that? Hey, so everyone can start their simulator now. If you've started it already, your simulation pane should be on the bottom right-hand side of your screen, and you can just click play. Now, because we don't have either of those variables anywhere in our logic, the easiest way to see the value of those variables is going to be to use the Watch tab. So there's likely one open in your project already from day one, but if it isn't, you can go up to View, Watch tab Page, and we're also going to open up View, Watch tab Page, in brackets, Table. So the table is for looking at arrays and structures. The regular page is looking at individual variables. So on the individual variable section, the Watch tab Page will throw in that word variable that you created. I called mine my word. And it will show us the online value, and it will give us the ability to modify it if we want. And now in our Watch tab Page table, I'll get everyone to add the Boolean array variable that they created. I called mine my bools. And that should display every index of that array in that watch tab page. Now, the value of your word variable is 0000. And because these are essentially linked together through that memory address assignment, it's made every single Boolean in there false. Now we can change the value of my word, and this is hexadecimal, by the way. So if I make it F0, F0, and hit enter, we can go to the watch tab page table, and we can see what that looks like in Boolean. And that's exactly what we would expect in Boolean. And alternatively, if we wanted to go in the other direction, we could flip bits true and false in our Boolean array, and we'll see that value reflected in the word. So I'm just going to go with a 1010 kind of pattern, and let's see what that gives us as the word value here. So AAAA is an alternating pattern of ones and zeros. So they're both going to reflect the contents of one another. So if you were to change the value of the word, the Booleans would reflect it. If you change the Booleans, the word will reflect it. It's essentially the last one that gets written to is going to be reflected by the other one. So logically in your program, if you were trying to convert a word into Booleans, you would be taking that word from your Ethernet IP data link or your Modbus register, and you'd be dropping it into the my word variable, and that array of Booleans will constantly be updated every scan cycle with the Boolean equivalent of that word. So was everyone able to fire up their simulator and do some Boolean conversion to and from the word? Is anybody having any issues?
So is the point of this that we could now use those individual bits in our logic if that's what we were trying to do?
Yes, yes, exactly. So I mean, in the example of, I have to go back to close to the start here. But if you remember making that structure when we had the VFD control word, this will be another way to get the bits out of that VFD control word. If all we were getting back was just a word of data, and we just had to pick out one bit from within that word of data, this would be a good way to do that. There are a lot of other uses for it. You can convert really anything to anything. You're often in conversion instructions in the PLC, you're often limited to what you can convert to what. With this address assignment, you can do a bit for bit copy from anything to anything. Converting a word into Booleans was just an example. Really, there's a lot of different things that you can do with these address assignments.
Can I ask a sort of related question?
Yeah, yeah,
Hey, look at there.
That's the content. So
So I'm not gonna lie, I got a project I'm in a bit over my head on because I'm new to all this Sysmac stuff, but I've been asked to find a way to get oh, my headphones are dying. data from analog instruments from the PLC to our like a SCADA data network. Are we going to cover anything like that or touch on it anyway?
Well, the communications class tomorrow, we will touch a little bit on OPC UA. Is that what you're planning on using, OPC UA, or do you know what protocol in particular?
I don't even know. I'm still trying to figure out how to get the thing to run. The pilots get how to run how we want it to run. But that was one of the items on my to-do list. So eventually I got to figure it out. But
Okay, so that would be a good one for session 5, where we're kind of, you can bring your application specific issue to us and we can kind of come up with a game plan on how to best solve it. That's essentially what we're doing session 5. You would definitely benefit from the next session on Thursday, which will be it's for communications. So you know, if you know what SCADA system you're using, the protocol that you're using, then there's a decent chance we might actually be covering that protocol on session 4. So
okay, yeah,
bit beyond the scope of today, but
sure.
and of course, you're welcome to. We can always take that offline too if we don't have a chance on Thursday, or it's something you don't really want to share with 20 other people. So
yeah, there's a lot of probably some IP involved. So
yeah, no worries. But yeah, that pretty much wraps it up for today. So I'm going to hang on for another 5 minutes here. If anybody was having any issues with anything today and you wanted to revisit it, that would be a good time to bring it up. Otherwise, enjoy the rest of your day, and I hope to see you on Thursday.
just real quick before you go, is it safe to assume that you're going to send out a follow-up with the video and the slides and everything?
Yes, sir.
Perfect. Thank you.
No worries.
Thanks.